Ladies and gentlemen, let me first introduce myself. My name is Petr Hořejší and I came to you from Czech Republic, Pilsen. Right now I work at the University of West Bohemia, Faculty of Mechanical Engineering, particularly Department of Industrial Engineering and Management. And we've been dealing 7 years so far with virtual reality. We are relatively a small team. It's just me and 2 PhD students who are stable ones, and we have also some normal regular students. So right now today I would like to tell you or show you some case studies in the, how to say, in ages, how we proceed, and at the very beginning of my presentation, I would like to show you some theoretical aspects, why the virtual reality is some topic which should be considered today, why it is or should be important for Industry 4.0. So, from my point of view, I would like to show you how we started on our journey of virtual reality. It was that day that we came to Skoda, a car, and we visited their prototype laboratory, and we were able to touch the prototype which didn't exist. They told us we would like to have this. So we made some application for a grant, and we made it, and we were able to construct some case, so-called computer automated virtual environment in our department. And from this point, we started to think what will be, which virtual content we filled inside this cave, inside this laboratory, because in that time we were so-called pioneers. It was a little bit complicated to do something, so we started to play a little bit. Before my talk about what we do and what we develop and what we try to make, let me just put virtual reality to a huge scope. I effort myself to pinpoint here top 10 actual trends according to prediction agency Gartner. So you can see that virtual reality is here in top 10. This is one, immersive experience. You should observe that right now the intelligence is something on the top. I mean the precipitation or forecasting algorithms, ranking algorithms, machine learning in general, and for instance, abnormalities detection, which is very necessary for security. In our company, some software that will intelligently recognize which one is abuse or strike. We are also talking right now about digital twins. We've seen it before. Something called like simulations with sensors, so digital twins. We are also returning from the trees something that was here out to the edge. I mean, right now some amount of computing performance is transferring back to workstations from clouds. So it is here, and also some event driven, which also belongs to the simulation. And the simulation. Okay. Let me first define some basic terms. I know that many of you know those terms just very quickly. Let me define what I will see about virtual reality, what will be the augmented reality, because I would like at the very end to tell you something about augmented reality projects. So virtual reality is somewhere here, when the user observes the virtual reality among him. Today it's not only the stereoscopic screen, but also the HMDs mentioned before. They have mounted displays, which it looks like that has the future. It's something that is bigger on the market and it's cheaper right now. And augmented reality is over here. I mean, it's something, it's the real environment filled with virtual objects, and somewhere between it, it's something called mixed reality. So after defining the basic terms, let me just tell you from my point of view where could be virtual reality applied in the industry. So the very first thing that we thought of dynamic prototype evaluation or verification. It's right now not so much need for maintaining or making some expensive prototypes. Right now I can see those prototypes in virtual reality. In virtual reality I have today's data. I can validate it not from the design side, but from my experience. For instance, I've been 14 years after this first introduction, I've been in Skoda Auto again, and we've been evaluating that motion capture suit, you know, that from movies, that the Andy Serkins wear some suit and plays Bloom, maybe no. So we went to the cave with this motion capture suit and were trying to reproduce some movements of water, and then we evaluated in a real time those movements. So that belongs also to another kind of application. I mean, ergonomical studies of many kinds. It's perfect. Virtual reality is perfect for using for it. You can use it also for virtual training somewhere where you have some expensive equipment. Where you need to make a training, somewhere where is a high fluctuation of workers. That's the kind where you can apply the virtual training. I landed a picture from Daimler. They have their own software for a collaborative VR, for collaborative work, environment where more workers from each part of the world can work together, communicate together, etc., etc. There are more softwares, for instance, ICIU software, which is being used by automotive right now, and also maintenance or high-end visualization. All those applications can be performed not only in virtual reality, but also in augmented reality, like you saw HoloLens from the previous presentation. Some of them are better to use in development. Some of them is better to use in the workshop or by foremen. I mean that only the visualization by 3D can be some value added for foreman in workshop. Why virtual reality now? If you observe Gartner curve, virtual reality is here, so it is something that will be normally used in scope of 2 till 5 years. Augmented reality is somewhere here, so it means 5 years to development of massive use in companies. So it's the general prediction. Right now, as you saw before, there is an ability to buy relatively cheap devices. As we started 7 years ago, I remember that everything is so much expensive. We started at somewhere 100,000 euros or something like this. Today you can buy this system, for instance, 800 euros or 1,000 euros, so it's a major difference. Just one curiosity, this device, only VR, right now it's impossible to get into Europe. I was trying very hard, but it's a great device. So, and right now, from the development side, many developers, mainly from Czech Republic, as far as I know, mainly those Prague firms, are right now not programming the environment from scratch. Like, I turn up Visual Studio, you know, and made the whole algorithms for wireframing and shading and shaders and program everything. It's not an option to do. Yes, it's an option, but today you have option to use some engines which will serve you with the basics visualization, or those are libraries for visualization with many plugins you can buy or download, and you, like a developer, take care only for the content of your simulation. For instance, we are using Unity 3, which is perfect thing. All those new virtual reality devices like HMDs or vans, etc., have direct support for Unity 3, also augmented reality. I saw Euphoria before in my previous speaker. There is also a support for augmented reality to 3D. It's perfect thing, perfect test bed. So the general outcome right now is mainly the high attractivity and lower costs, mainly in prototyping phase, and you have seen those possible applications before. And right now let me shift to the practical part of my presentation. I would like to present you some virtual, or not only virtual devices on our department. This video is a little bit older, but I have nice PhD students who are elected here. So this is that laboratory that we were able to build 7 years ago. This is only one screen projection where you have the possibility to have stereoscopic glasses. You are tracked, so that means that the system knows where exactly you are in the so-called tracking space, and it adjusts the environment to your use, and also we have some event. So those are our first tryouts. We were inspired by PSA, and Citroën Peugeot Association, where I saw their first application in VR. They had an application where for virtual training, where the worker needs to apply some specific, very expensive glue in the inner side of car doors. So we tried to replicate this simulation. We also tried to make some trainer. For our point of view, we wanted also to have some virtual tours, not only for the visualization reasons, but we wanted to have some environment where we can measure something, where we can do some small simulations, but we would like to have also the visualization outcome and the virtual reality devices support. In those times, there were only few softwares. This one cost something like 30,000 euros, so it was impossible for us to buy it. So we decided just to make our own environment where we can model the workshops and make layouts and make it directly in 3D and make those virtual tours and maybe to have some virtual training in it. So we decided to use the source SDK environment, which is the basis on which are based some computer games, like Half-Life 2, maybe you know Counter-Strike, which are games which are based on this engine, this basis. This environment is the editor which comes with computer games. And we just simply, not so much simply, okay, we just tweaked it. We developed a library with some 3D models, with some logics of control. You can see here some conveyor belts. So if you are building some conveyor belts, you are just putting those Lego bricks together. And in this video, when you know how to work with it, you are able to make this simulation, this visualization in 20 minutes. So we don't speed it up. So just 20 minutes, this kind of visualization. You can measure there something. You can measure some batch sizes and waiting times, etc., etc. Like in the simulation, but the second output, the first output is the visualization for us. So you can see that you could make some virtual tour in it using some devices of virtual reality. We also were able to do some better simulation, better virtual trainings. So you could see just a little show house, a little beak to some lighting simulator. After this simulator, I don't have it in my presentation, but we have some complex trainer which was being tested on Department of Construction on students, where you received operational manufacturing list, what to manufacture first and then you go to the machines and you need to build this part. So right now we are about to release a paper, so we are right now finished about it because of the long time of validation. I've been able to use this environment in teaching, so for 4 years I've been using it for teaching. Our students develop some particular companies or something they invented, or this is our university from the front. And then we moved a little bit forward. So we left this environment just because of some licensing problems. We simply couldn't use it for commercial use, and we tried, or we made something our own. So we developed our test bed, our layout maker, which was used especially for testing of point clouds, which were acquired by 3D scanner, for development of our algorithms, which we call slicer. It's able to, when you make a 3D scan of a shop floor, then this algorithm is able to make some slices, and those slices you put in CAD program and make reconstruct this shop floor. So it would be useful. The second reason why we needed this test bed is the ergonomics part. So we would like to connected it with Kinect, which I showed you, which I will show you just right now. And we were able to make evaluation according ARCHEC norm, which is something that didn't exist before. So for this project we used Microsoft Kinect, which is able to shoot human body motion. So we were able not only to use some method like Narula or NIOSH or something maybe some ergonomic evaluation like this, but we were able to make that check norm, which was nowhere because it's dynamic. It's measuring actually the time between the movements. So great thing. And let me just tell you something about the virtual training. You see something before, and some applications from our colleagues from Slovakia. This is a great thing. We did this one, but I like this application. Our colleagues from Žilina in Slovakia, they did a huge trainer for Skoda car. It is for that maintenance of KUKA bots, or KUKA robots. They have the manufacturing line, long manufacturing line, which consists of these KUKA robots. And when they would like to train how to make the maintenance, it will mean to stop the whole line. So they made this particular trainer, virtual trainer, which acts like a game. They have two terminals. One terminal, there is a teacher which tells the student what to do, and they reacted to a specific tasks they observed in practice. For instance, there was something spilled in the corner, and in the future there was a fire because of it. So they implemented it in their simulator. Something is here. If you don't observe it, you have minus points, etc. So it's like a game. So it motivates them. We also developed our own simulator like this. This is a simulation which was developed for HMDs, for head-mounted displays. Our PhD from Georgia did this simulation, and one curiosity is that when you make some maintenance on this car, I have only a little bit part from this what you can do in this workshop. Great thing is that when you make all the maintenance and everything on that car, you can drive it actually. And one perfect curiosity, we are in connecting with the psychiatrics department of our hospital, or faculty hospital in Pilsen, and my friend who is working there used this simulator on one patient who was scared in a car, you know. So in this simulation you can simply click, and he will sit in front. You can simply click, he will be on the back. So he trained those situations. According to it, he told he helped it a little bit. They were trying a small speed, you know, but it's a little bit realistic, so it worked. On those simulators, we were also validating two aspects of virtual reality: knowledge acquisition, which means that we were comparing the normal stereoscopic projection like in movie and HMD and normal PC workstation, and we, for our students, 83 students, whatever. So for our students, they had some layouts of companies, and they needed to make some virtual tours, and then they received some dictionary. How was the concept of manufacturing? How many machines you saw there? So we had some questionnaire about knowledge acquisition. The result is the same. You can see that on the HMD we have a few problems, only 54. So the knowledge acquisition is the same in stereo projection and in Swift. But the problem was some cyber sickness. Maybe you know that the illness or disease from virtual reality, which is defined by more than 50 aspects. You can find it something like cyber sickness questionnaire. We're also collaborating on it with our psychiatrics. So you can see that by using of HMD, the probes were perceiving some of those symptoms. Right now, we made this research again after 2 years, because we were testing Oculus Rift DK2, and it's much more better. So our result is that there was a technological barrier. I mean, latency of the picture is the problem. So, augmented reality. So, and the very ending. So let me show you some steps of ours with augmented reality. So this is our first try. When we when we have this workplace and put the camera in back of the worker, and it is very simple because we have only marker, one marker is one. So only one marker by which the camera knows the plane of the table and is able to project some steps on the monitor. In the next version we have also some arrows, you know, where to take the parts. Right now we have our own system which we made in Unity 3D. We also use Vuforia for it. This is a great system. This is compatible with Unity. This is the screen which could be projected on the screen of laptop or cell phone, and we have our own environment where you simply edit how looks like the registered environment. Actually, this is motherboard for this case. How will look like each step? I mean, what to do. So we developed our software for making manufacturing instructions. It works not only in the augmented reality, but the second version can be projected in front of you on monitor, and you don't need some cameras or some devices, if you would like to know. So this looks like on the cell phone. So Unity 3D and Vuforia select those systems. And okay, last but not least, no, this is last thing. One project which I'm particularly proud of because we were able to interconnect this Faculty of Design and Arts. We made a game. This is not virtual, non-VR training, only 2D training, and we developed a game for not mechanical, industrial engineers. So you are in the role of a manager who is in his work on his job for the first day, and he receives a task to explain to workers how works Kanban. And you go to the Tracy, which is your secretary. You receive some tablet where you can learn about what Kanban is. And then you go to the manufacturing hall and talk to the worker, and according to your responses, according to talking with him, you receive some points and you get motivated. And if you will do it well, then you will be rewarded by some cutscenes. I mean, in the very end here will be some cutscene or sub-quest. The worker is missing, you need to find him. And for the second day there is something like in time, and we did 5 advice and I think two more methods, so it explains those methods of industrial engineering. So I saw you in my, I like to summarize it. I show you some reasons for virtual reality. I showed you some case studies, and if you like, maybe we have a little bit of time, I can show you one more which we are doing in collaboration with those psychiatrics. Okay, but it's not industrial engineering, I warn you. We made a concept of virtual pub. It's a virtual Gaststätte. Virtual pub. It's the simulator for addicts, for alcohol addicts. We've been developing it for 5 years, and I'm very pleased that last month we have first patients who tried it on their own skin. So I'm very glad we are proceeding somewhere. So the concept is very basic, that the proband, the alcohol addict, who tells to his doctor that I think I will make it. So he will be facing his, not nightmare, I have to say, his critical environment. So he will be facing this virtual pub. So the main point here is the audio. because there are some Czech, this in Czech, I'm sorry. So there are some phrases that are provoking him or provoking you to have a drink. You can simply sit here. It's a justice for HMD. So this scenario is based, you just came to the pub because it's socially normal to get a pub, you will have a meeting. It's everything you will get. And here you will get one message that the friend will be a little bit later. Then you get another message that the friend won't come at all. And then you have 10 minutes in this so-called Q exposure therapy. So everyone here will provoke you to drink something. So I can order something, for instance, a beer. I can sit here to my friends who will be provoking me, I'm quite for sure. You could hide down there in the bathroom. What is not the great behavior, which will be also evaluated. So it is the basis for after drinking, I think, one beer, I will get the blur vision. They will tell me another thing, like he told that he is cured already. If you don't drink, so they will provoke you something like you came here only for walking, or you will be drinking, or something like this. We have categorized those phrases to 5 categories. So we expect 3 exposure at least for one problem, for one addict, because we would like to put outside some research outputs. So that's it for just. Thank you for the attention. And if you have some question, I will gladly answer. Thank you.